been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for chapter 2.3 over deductive reasoning. So there's 3 vocabulary words that you need to know and write down in your notes. If you want to put these vocab words with your other vocab, that's fine. I've just included it as part of the video. So deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. As part of deductive reasoning, we have what is called the law of detachment. This is if a conditional statement is true and the hypothesis is true, then the conclusion is also true. For the law of syllogism, that says that if P then Q is true, so if a conditional is true, and then another conditional Q then R is true, then P then R must be true. So I'm going to go over what this looks like and some examples. So for the law of detachment, okay, so again, if P then Q is true and P is true, so remember this is the hypothesis, then the conclusion must be true. So here's an example. If 2 numbers are odd, then their sum is even. Now, that has to be true. Is this true? Yes, this is true. There's not a counter example I can bring up that would make that not true. 2 numbers are odd, so 3 plus 9 is 12. You can add any odd numbers, you'll get an even sum. So because that's true, then if 3 and 7 are odd numbers, that is your P. And that is true. 3 and 7 are odd numbers. Then the conclusion must be true. That means the sum of 3 and 7 is an even number. And so that's where your conclusion comes in. So you kind of want to think about it as you're sort of substituting this into the original conditional statement for your hypothesis. So it says if 2 numbers are odd, that's general. Well, we're saying, okay, what if it's 3 and 7? Those are odd numbers, so we're putting that into our hypothesis. Then because that fits the hypothesis, then the conclusion of them being the sum is even must be true. That is the law of detachment. The law of syllogism says that if P then Q is true and Q then R is true, then P then R is Q. It's kind of like the transitive property. So, an example, if Mary gets all A's, then she will get a car. So this is P and this is Q. If she gets all A's is the hypothesis P, then she will get a car is the conclusion Q. Now in the next example, in the next line, it says if Mary gets a car. Well, that's the conclusion from my previous statement, but it's now the hypothesis of this statement. If Mary gets a car, then she will go to every football game. So that's now the conclusion of my second statement. So using the law of syllogism, what could we conclude? So if P then Q is true, Q then R is true, then we can conclude that P then R is true. So the conclusion is going to be if Mary gets all A's, then she will go to every football game. So again, if Mary gets all A's was our P, she will go to every football game is our R. And we can conclude that because both P then Q and Q then R is true. And that is called the law of syllogism. So just real quickly, a review of inductive versus deductive. Inductive reasoning is what we studied in the last section. It's based on observation, it's using patterns, and it goes from specific to general. So for example, I have a specific example, 3, 5, 7, 9. What's the next term? The general would be that, for instance, the next term is always going to be 2n plus 1. So if this is the first term, second term, third term, fourth term. This is specific, and then here is our generalization. Whereas in deductive reasoning, it's based on known facts. You use definitions and postulates and accepted properties, and it goes from general to specific. So you have a general case, and then you essentially make it specific to whatever you're looking at the time.
I've been waiting way too long. Yeah.